Hi, everyone. Today we're going to start talking about statistics, which is one of my favorite subjects in math because it's just so different. It's where we have the opportunity to analyze data that's presented to us in the media, on television, and things we read, and be critical about the information we're given so we can make the choices that are right for us. So when we start a new unit, it's always important to get familiar with the vocabulary. So today is going to be a lot about vocabulary. So the first thing we're going to learn is the word population. And population means everybody. It's a large group that we want to know something about. A parameter is the thing we want to know. And that could be anything. That could be people's favorite preferences, who they're going to vote for. It could be health things about them. It could be anything you can think of. It's the thing we want to know. Now, here's the thing about statistics. It's almost always impossible to talk to everybody in a population. You can't talk to every single person that you want to talk to. So we get some representatives. And we call those representatives a sample. And a sample is the small group we survey that represents the population. Now, we're going to study that smaller group and we're going to get some information. And we're going to get that information called a statistic. It could be a percentage, it could be a favorite thing. So a statistic is based on the sample, and it allows us to infer what is true about the population. Statistics are limited because we're only talking to a small group, but if we pick our small group wisely, then our statistic is a good representation of our population, aka everybody. So here's an example. The National Endowment of the Arts conducted a survey called Reading at Risk on the reading habits of 17,000 adults. Of those surveyed, 57% read a book in 2002. So, the National Endowment of the Arts, by virtue of being national, wants to know about everyone in the country. So, all adults in the nation. But since it's not possible for them to talk to all the adults in the nation, they pick a sample, a representative group of 17,000 adults. What's the thing they want to know? Who read a book? And the statistic is 57%. That is the thing that they learned. 57% of people read a book. That means that they can infer that about 57% of people in the nation read a book. They can't say for sure, but it's a good estimate. It's a good representation. All right. A recent survey by the alumni of a major university indicated the average salary of 10,000 of its 300,000 graduates was 125,000. That's pretty good. So the population is all the graduates. That's what they want to know about. So the 300,000 grads. But instead of talking to the 300,000 grads, they only talk to 10,000 of them. What did they want to know? Their average salary. And what did they learn? That the average salary of the small group was 125,000, and that lets them estimate the average salary of the big group, the population. It's probably not exact, but it's a good guess. So if you were to do this in class, we would talk about something silly. You want to know everybody's favorite blank at Millbrook High School. I'm going to say ice cream flavor. You want to know everybody's favorite ice cream flavor at Millbrook High School. you will survey 40 students. So what's the population under investigation? Everyone at Millbrook High School. But the sample is just 40 students. What do we want to know? Their favorite ice cream flavor. So, to get the most representative statistic, how could we choose 40 students to survey? You could talk to the next 40 students you see. You could choose 40 random names from the school roster, or you could randomly choose 10 students from each of the 4 classes. Which one of these options do you think would give you the best snapshot, the best representation of Millbrook High School? It's probably not number 1, because if you talk to the next 40 students you see, they're going to be students who are like you. That doesn't represent all the different kinds of people, different ages, different beliefs, different choices of Millbrook High School. So option 1 isn't the most representative option. Option 2 is a little bit better. Choose 40 random names from the school roster. That's better. But option 3 means randomly choose 10 students from each of the 4 classes. That means you're going to get 10 freshmen, 10 sophomores, 10 juniors, and 10 seniors. And that's actually a better representation of Millbrook than just choosing 40 random. If we randomly choose 10 from each class, that's going to be the best snapshot of Millbrook High School. So this last question is a lead-in to what we're going to talk about next, which is how do we design a sample? We want to make sure that we choose our samples so that they represent the population the best it can. If we're going to pick a small group, we want to make sure that small group looks like the big group. So the way I've seen it described before is if this is your big group and we've got 6 purple dots and, oops, I tried to change my color. And 2 blue dots, or let's do 3 blue dots, then if we choose a sample of that group, sorry, my pen's going crazy, there we go. We might choose 2 purple dots and 1 blue dot. Notice how the ratio is the same. For every blue dot, there's 2 purple dots. Our sample, our small group, represents our big group. So now we are going to talk about 5 different ways to sample. And depending on the situation, one sample design might be better than another one. So the first sample design is called a simple random sample. And you might see this sometimes as SRS for simple random sample. With a simple random sample, all population members have an equal chance of selection. So an example of this is if you draw 5 names from a hat, everyone is equally likely to be chosen. Now, another type of sample, and this is one of my favorites, it's called stratified random sample. The word stratified just means sort. We sort our data into groups, and then we pick randomly from those smaller groups. So we sort into subgroups, And then we randomly choose from those subgroups. And those subgroups have a special name. They're called strata. And that makes sense because this is stratified. That was supposed to be a highlighter. Whoops. There we go. Stratified. The word strata comes from stratified, which means to sort. So we sort into subgroups and then we randomly choose from the strata. So, for example, we make subgroups ages 20 to 30, and then another group of ages 30 to 40, and we choose 10 people from each. So we sort first, and then we do an SRS, a simple random sample. That allows us to get a sample that represents the population a little more than just picking 20 random people. The third sample type is called cluster. And I don't know why when I hear cluster sample, I always think of a cluster of grapes. So here's my drawing skills. There you go, cluster of grapes. That means that if there are pre-existing groups, you survey everyone in one of those pre-existing groups. Sorry, y'all, my notes app is struggling today. There we go. Survey everyone in pre-existing group. So an example could be to choose 4 towns in North Carolina and survey everyone in each town. So the difference between stratified and cluster, in stratified, you do the sorting yourself. In cluster, the groups exist already. So like a group of grapes, a cluster of grapes, those groups already exist, and you just come in and you talk to everyone in the pre-existing group. So strata, you make your own groups. Cluster, the groups exist already. Okay, 2 more to go. Systematic. The root word here is system. You have a system for choosing people. It's where you choose every nth person. And nth is just a placeholder for some number. So for example, you pick every 3rd person on the class roster. So you count 1, 2, 3, you, 1, 2, 3, you, and that's how you pick people. Okay, so the last one is a pretty bad way to sample, but it's more common than you might think. It's called convenience sampling. And convenience sampling is where you choose members of your sample that are easiest for you to access. So survey the next 8 people you see. That's not a great way to sample because it's very rare that a convenient sample gets you a small group that represents the big group, the population, in a good way. So here are some examples. We're almost done. We're just going to identify the sampling methods based on the scenarios. So every 5th person boarding a plane is searched thoroughly. Every 5th person is a system. This is systematic sampling. All right, number 2, at a local community college, 6 math classes are randomly selected and all the students from the classes are interviewed. There's 2 clues here. The first one is that the math classes are clusters. They are groups. You didn't make the groups yourself. When you make the groups yourself, it's called strata. These classes already exist. The other clue is that all the students from those clustered are surveyed. When you do stratified, you only from small groups. With cluster, you do the whole group. So this is cluster sampling. Number 3, a researcher randomly selects and interviews 50 male and 50 female. This is stratified because the male and female groups are groups that you make yourself. Teachers aren't automatically sorted into male and female. These are groups you make yourself. So this is stratified because there's 2 strata here, male teachers and female teachers. All right, the next one. The name of 70 contestants is written on 70 cards. They're placed in a bag, mixed well, and 3 names are picked from a bag. This is simple random sampling. No sorting, no groups, just put all the names in the hat, pick a few. And then finally, a community college student interviews the first 10 students to enter, the first 100 students to enter the building. This is convenient sample. It's not random at all. It's just what's going to be easiest for the surveyor. So this is convenient sampling. All right, so that is your start to vocab for statistics.